What's up, my people? This is Mr. Tui, creator of the SAT Crash Course series. And in this video, I'm going to teach you the easiest and fastest way to solve questions from Digital SAT Practice Test 1, Math Module 2. If you like this video, make sure to like and subscribe down below, and be on the lookout for more Digital SAT videos coming out soon. In the meantime, enjoy these answer explanations from Digital SAT Practice Test number 1, Math Module 2. Welcome everybody to Digital SAT Math. This is Practice Test 1. We are on Module 2. Starting at the beginning of Module 2, we're going to work our way through the questions. We've got Tanner with us today, guiding us through. Tanner, say hello to everybody, please.
Hello.
All right, thanks, Tanner. Appreciate it. And we got a question up on the screen, so let's just jump right into these questions and answer explanations. Go and read question number 1 for us, please.
Tilly earns P dollars for every W hours of work. Which expression represents the amount of money in dollars Tilly earns for 39 W hours of work?
Yeah. What are we solving for here? Tanner, do you have any idea?
An expression based off of the numbers given to find the amount of dollars.
Yeah, the amount of dollars that Tilly's earning for 39 W hours of work. Now, this is funny because this is the first question on Module 2. Generally, they start off with the easier questions. Of course, the digital SAT is an adaptive test, right? So if you're getting the harder questions, if you're getting the easier questions right, they'll give you some harder questions. If you're getting the harder questions wrong, they'll give you some easier questions. If you're starting off with an easier question here in this module, but I think this is deceptively tricky because I look at this expression 39W and I'm like, I don't know what that means exactly. What does 39W mean? It's not super obvious to me. I don't think it's super obvious to most students. I mean, do you know what that means, 39W? Or maybe not so much.
So 39 hours?
Well, it's not. It's 39 W hours, right? And that's what's tricky about it, because W is hour. It's like, what does that mean? Here's what I want to do, Tanner, because this is really tough to develop this expression. I think it is. I want to plug in some values. We're going to follow that first rule for SAT math. If we go back to that real quick, remember my first rule is to avoid algebra whenever possible. Plug in values for the variables. And I think that's the case here as well. I want to plug in values in place of these variables, and I think the question is going to be a lot easier if we do that. So I'm going to start with a value for P, which is the number, the amount of dollars he's earning for some number of hours. Okay, can you give me a value for P? That's the number of dollars for some number of hours.
1.
We could do 1. We could do 1 here. I want to make it a little bit more realistic, though. You know, I mean, we have minimum wage laws, right, in this country, that are sometimes followed. And I'm just going to make it. I don't even know, honestly, know what minimum wage is, but it's somewhere around $7 or $8. I'm just going to make it $7. Okay. So I'm going to set that value. P is 7. You could probably do 1. You'd probably survive if you did that. But I'm just going to make it 7 here. I just want to kind of do this to wrap our heads around this a little bit more, make it somewhat realistic. So Tilly earns $7 for every W hours of work. And I'm going to create a value for W here as well. Now here I'm going to make W equal 1. Let me explain why. If I make W equal 1, then we can say Tilly earns $7 for every 1 hour of work. So Tilly's earning $7 an hour. Does that make some sense? Or no?
Yeah.
Yeah, $7 an hour. Okay, great. Now the question's a little bit different. If W is 1, the question's much more clear. The question is just how much is Tilly earning for 39 hours of work if W is 1? Does that make some sense? Why we're just finding out how much Tilly earns in 39 hours. And Tilly's earning $7 an hour and working 39 hours. Do you see how to calculate how much money Tilly's earning? Do you know how to do that?
Yeah.
How do we do that?
Multiply.
Just multiply them, right? It's just 39 times 7. So let's do that real quick. Let me know what you get. Just punch that deal calculator there.
$273.
Yeah, $273 for 39 W hours of work if W is 1. Does that make some sense?
Yeah.
Okay. So the right answer has to give us 273 when P is 7 and W is 1. Does that make some sense?
Yeah.
Look at the answer choice. You might be able to just look at them right now and tell me what the right answer is. I'll bet you can. Because it's basically the calculation we just did.
It's going to be A.
It's going to be A. Absolutely. It's A, right? Because if P is 7, we're going to get 273 when you multiply them. And that's the calculation we did. Does that make some sense?
Yeah.
I think the best way to do it there is just create some values. Would 1 and 1 have worked? Maybe. In fact, I think it probably would have worked because then you'd be making $39 and you got to pick the answer that gives you 39. So yeah, I think A would work as well if you did 1 and 1. Again, I want to make it somewhat realistic and work within the requirements of labor laws in the United States. But does that make some sense how we approached it there?
Yeah.
But I remember seeing it for the first time, trying to think in terms of the variables, and I was just kind of confused. It wasn't super obvious to me. But plugging the values is pretty easy. Questions about that?
No.
Okay, great. Let's keep rolling. We're just going to work our way through these. Next up, believe it or not, is question number 2. So let's take a look at it and see what we got here. All right. Go and read question number 2 when you see that on your screen.
For a training program, Juan.
Yeah, well, I think that'd be Juan, right? Juan?
Juan?
Yeah, Juan. Mm-hmm.
All right, that works. Rides his bike at an average rate of 5.7 minutes per mile. Which function M models the number of minutes it will take for Juan to ride X miles at this rate?
Ooh, what are we solving for here?
A model for the number of minutes it will take to ride X miles.
Yeah.
At the rate given.
Yeah, at the rate of 5.7 miles per minute. This reminds me a lot of the last question where it's like, man, just thinking in terms of like creating an expression or developing an equation is tricky. It's tricky. And I'll be honest, like I struggle with that. I think most students I work with do as well. I mean, do you have any idea, just sort of based on the question, what the equation is going to be to model the number of minutes it's going to take them to ride some unknown number of miles? Do you have any idea or no?
It's going to be a multiplication problem, but...
Yeah, there's a good chance. Yeah. Which would make it what, do you think? What would the answer be?
Probably D.
Probably D because we've got multiplication there, right? That's really reasonable. And I like that, right? You're like, I'm probably doing some multiplying here. If that's obvious to you, then you can sort of gravitate towards D. And if that's as far as you get, you're making a reasonable guess, and I'm good with that. Okay, let's see if we can confirm that. We're going to follow that first rule of plugging in values in place of the variables, because we can plug in values for M and X, and it's going to make it really easy, I think. Okay. So let's start with, we're going to plug in a value for X, the number of miles he's riding. Okay, the number of miles he's riding.
Okay.
Give me a value for the number of miles he's riding.
Let's do 3.
Let's do 3. I love it. Let's do 3 miles. So X is 3. So he's riding 3 miles. Now, just logically, we can easily figure out how many minutes it's going to take him to ride 3 miles, right? Well, maybe not logically. I think we might have to do the calculation, but it's obvious, I think, right? How do we calculate how many minutes it's going to take him?
Just multiply.
Once again,
by 5.7.
Absolutely. Do it real quick. Let me know what you get. So 3 times 5.7.
17.1.
Yeah, so the number of minutes equals 17.1. So we know when X is 3, the right answer also has to give us 17.1 when we plug it in.
Mm-hmm.
I don't even think we need to plug in to some of these answers because they look silly. When we plug in a 3 for X, we're not going to get 17.1. What can we get rid of right off the bat?
We can get rid of A.
Yeah.
C and B.
Yeah. They're not going to give us 17.1. And of course, we look at answer choice D. That's the calculation we just did. 5.7 times 3 to get 17.1. So it's got to be answer choice D. Questions about that? Or does that make sense?
No.
Okay. Once again, plug-in value is really handy. But I like the fact that your instincts were, basically gave you the answer. They're like, I think I'm doing some multiplying here. If that's obvious to you, great. You can think in those terms. If it's not so obvious, and it wasn't obvious for me, I'll be honest with you, then just look for a way to plug in the values. I think you could survive here even if you made like X1, right? Because it would take 5.7 minutes for him to ride 1 mile. Does that make sense?
Yeah.
So the right answer would have to give you 5.7 when X is 1. Answer choice D would do that as well. So that even works here. But I like plugging in that 3. Sometimes if you plug in like 1s or 2s, you'll get multiple answer choices that give you a true statement. You got to be careful there, test them all. But 3 works nice here. Some other values would work too. Great job, Tanner. Let's keep it rolling. All right. Go ahead and read question number 3 for us when you see that on your screen.
3x equals 12 and minus 3x plus y equals negative 6. The solution to the given system of equations is x and y. What is the value of y?
Ooh, what are we solving for here, Tanner?
The value of y.
Yeah, we're solving for the value of y. Now, this is a systems of equations question. You've seen these before at some point in math class, I'm assuming. Is that correct?
Yeah.
Yeah. Do you know how to solve systems of equations? Are you relatively comfortable with that or not so much?
I'm fairly comfortable with it.
Yeah, there's two methods. Anybody watching this recording, you might be familiar with these two methods. One is called the elimination method, which is generally what I recommend on the SAT. That's just more useful, the vast majority of the time. Sometimes you can also do the substitution method, which if they give you like the x value, you just plug that in, you can solve for y. Have you heard of both of those methods for solving systems of equations?
Yeah.
Yeah. And, I suspect as we work our way through the practice test, we'll use both at some point. But here I'm looking at this question. Notice the first equation they give us, this 3x equals 12. Like, we can solve for x right off the bat there. Do you see that? Just kind of looking at that. In fact, you might even be able to tell me what the x value is. Does that make some sense?
Yeah.
Yeah, what would the x value be? Just looking at that first equation, what would the x value be?
4.
Yeah, it's got to be 4, right? I mean, divide both sides by 3. Yeah, of course, x is 4. I'm going to make a note of that here, that x is 4. That's going to be handy. And here, I guess, really, to solve for y, then we just have to plug in a 4 into the bottom equation. And we could solve for y. Does that make some sense?
Yeah.
Yeah. Let's do that real quick. And let's see what we get for y. Let me see you plug in a 4 for x into the bottom equation.
Okay.
Looking good. I'd use parentheses here as well just to make this really clear. That's 3 times, negative 3 times 4. That's fine. We had works too. And then what do we do next? Solve for y.
We can, one second.
Now, why are you subtracting 3 right there? I'm a little bit confused.
I'm substituting for y, adding in these variables for y.
I see. You're testing the answers. I see. We could do that. Yeah, that would totally just see if we get a true statement. I see what you're saying. Are you trying to avoid the algebra here?
Yeah.
I'll bet you could do the algebra. In fact, I want to do the algebra. Sometimes, I'm not completely opposed to doing the algebra. In fact, about half the time in systems of equations, doing the algebra is going to be the fastest way. I think I'd rather do the algebra here, but I do want to point out that, yeah, there's a path there also. You could just plug in the answer choices. But let's do the algebra here. So let's, I'd start by simplifying, what's negative 3 times 4?
Negative 12.
This is negative 12, and I'll write that down. So we get negative 12 plus y equals negative 6. Now let's solve this algebraically from this point. How do we solve for y? We're just one step away.
Yeah, we just find what the difference is between negative 12 and negative 6, which is 6.
Yeah. Or you could say like add 12 to both sides as well. That would work also. And then, so what's negative 6 plus 12?
Negative 6 plus 12 is 6.
It's just 6. What's the answer?
6, which is D.
There you go. Booyah. Questions about that, Tanner?
No.
Okay. But I like your instinct there of like, well, they give us the values for y. Let's just plug those in and see what happens. If the algebra wasn't obvious, you know what I'm saying? Absolutely. That's a great way to do it. I love that. But here I think the algebra is pretty straightforward. I think it's definitely within your skill set. You've got options. It's funny. I'm looking at this question right now. I realize there is another way to solve this using elimination, which might even be easier than what we just did, either of the paths that we were talking about. I want to talk about it real quick. I mean, do you realize you can add and subtract equations, kind of like you add and subtract, any sets of terms? Are you aware of that?
Yeah.
Yeah. If you added those equations together and just combined the like terms, you'd get y right off the bat. Because you'd combine these terms here. If you're familiar with the elimination method, this will be obvious. Again, we'll get to it in a little more depth probably at some point, some other questions. We can add those terms together. What's 3x plus negative 3x?
X.
No. What's anything plus its opposite? I mean, what's 3 plus negative 3?
Oh, 0.
0. 5 plus negative 5 is 0. X plus negative x, or x minus x, same thing, is also 0. Anything plus its opposite, 0. I know you kind of focus on like, well, aren't I supposed to just like add the coefficients in front of those? And you can. You know, if you add 3 plus negative 3, you'll get 0 and then leave x. But 0x is just x. Or sorry, 0x is just 0. Sorry, 0x is 0. So that, essentially they cancel each other out. Does that make some sense? Why you can just cancel those out? Get rid of those?
Yeah.
Yeah. So that's gone. And then I'll just drop the y because y plus 0 is just y. So that gives us y right there. And then it equals, we'll combine like terms again. 12 minus 6. What's 12 minus 6?
6.
Just 6. And there's your answer right there. That it's actually kind of set up nicely for elimination if you realize you can just add those equations together. Does that path make some sense?
Yeah.
Yeah, because they give us that first real simple equation, 3x minus 12, right off the bat. I was like, I can solve for x. Once I got x, I can figure out y, no problem. So lots of paths there on that question. But, take whatever path is easy and obvious to you. But if you try one path and it doesn't, try elimination, it doesn't work, well, try substitution. And try substitution doesn't work, try elimination. Try plugging in the values in place of the variables. So that works here as well. So you've got a lot of options. Any questions about that, Tanner?
No.
All right. Let's see what's coming up next. Ooh. Go and read question number 4 for us, and we'll discuss it.
S equals 40 plus 3t. The equation gives the speed s in miles per hour of a certain car t seconds after it begins to accelerate. What is the speed in miles per hour of the car 5 seconds after it begins to accelerate?
Ooh, what are we solving for here, Tanner?
The miles per hour it takes the car to accelerate to in 5 seconds.
Well, that's not quite what the question's asking us. I want you to read the last sentence of the question. Again, what we're solving for is always in the last sentence. Read that last sentence again. Let's make this really clear.
What is the speed in miles per hour of the car 5 seconds after it begins to accelerate?
Yeah. So we're solving for the speed in miles per hour of the car 5 seconds after it begins to accelerate. That's what we're solving for. Does that make some sense?
Yeah.
Yeah, I think you said something slightly different. I just want to make it really, really clear. And if it's not obvious to you, if you read through it, like, it's not super clear, read it again. If you need to read the question 2 times, 3 times, if you don't understand the question, it doesn't matter what you do. You've got to really take the time to understand the question. I can't emphasize that enough. So we're looking for its speed, okay, which is the s value for some number of seconds after it begins to accelerate, okay?
Yeah.
All right, so, boy, this is also a plugging in values question. Because we're looking for the speed after 5 seconds. Well, 5 seconds, that's a value, that's a term in the equation they give us. What term is that?
Five seconds is the t term.
It's the t term. Because t is the seconds. So literally, I think all we have got to do here is just plug in a 5 for t, and I think we'll get the right answer. Does that make some sense?
Yeah.
Yeah, do that real quick. Let me know what you get. And I'm going to write this out while you're working that out.
Yeah.
For anybody watching the recording. So it's going to be S. That's not a 5. Let me make that real clear too. S, there, it's a better S. S equals 40 plus 3 times, but not t, the t value is 5. So what's that give us?
55.
55.
For the speed.
Yeah, it's choice D, absolutely. Any questions about that?
No.
Okay. What makes this a little bit tricky, we're asking for the speed, which is the s value, and then like the number of seconds isn't s, right? The number of seconds is t, which should make sense, right? Because that's the time in seconds, right? You're not plugging in 5 for s, you're plugging in 5 for t. You just got to make that really, really clear. But if you can keep all that straight, I think it's pretty straightforward. We're just plugging the values here. Questions about this?
No.
Okay. Again, the level of difficulty is going to bump up a little bit, but if you can understand that question, that's a breeze. All right, this is going to get a little tricky here. Go and read question number 5 for us. Let me see that on your screen, Tanner.
Note the figure is not drawn to scale. For the right triangle shown a equals 4 and b equals 5, which expression represents the value of c?
Ooh, what are we solving for here, Tanner?
We are finding the value of c for
value
this.
C. Yep. And do you see c in the figure? You see it?
Yeah. It's the long side.
It's the longest side. They call that the hypotenuse. It's the longest side in a right triangle. It's the side that's always opposite the 90-degree angle, which is the biggest angle in a right triangle. Okay. Now, I don't know if you're familiar with the Pythagorean theorem. Are you familiar with the Pythagorean theorem? Have you heard that term before?
Yeah, I have.
Yeah, I don't know if it's obvious or not, but they're definitely testing us on the Pythagorean theorem. I'm just looking at the answer choices, and we've got stuff inside like square root signs and all that. And that's probably the easiest way to do this. I mean, we could sort of like redraw this to scale. There's probably another path with redrawing this to scale. It might not be a bad way to do it, actually. We'll talk about that here in just a minute. But let's start with the Pythagorean theorem, because if you're familiar with it, this is totally doable. Do you know the Pythagorean theorem like right off the bat? Do you have that memorized?
No, I don't have it memorized.
That's okay. No big deal, because they give you the Pythagorean theorem at the beginning of each math module. So I want to go to the practice test real quick. You should have access to that. Go and bring that up. I'm going to bring it up on my end. I'm at the very beginning of module 2. The same page basically is at the beginning of module 1 as well. They give us a bunch of formulas. We've got formula for like the area of a circle, circumference of a circle, area of a rectangle, area of a triangle. And then the fourth equation they give us, or maybe the fifth, but the fourth figure is the Pythagorean theorem. Do you see it right there? Yeah. So tell me real quick, I'm just going to write this down on the whiteboard. What is the Pythagorean theorem? We're going to need this to solve this question.
C squared equals a squared plus b squared.
Yeah, absolutely. And let me make it real clear what these values represent. The a and b values are the legs of a right triangle. Those guys right there. And then the c value is the hypotenuse, the longest side of a right triangle. So if you know the legs, in this case the a and b values, which they give us, you just square them, add them together, and then you'll get the c that equals the c squared value. We're going to have to do some algebra here and probably take the square root of both sides to find out what c is. But we just plug those in and kind of calculate it, and then we should be able to find the right answer. Does that make some sense?
Yeah.
And they were kind enough here to make like the legs are a and b. So we're just going to plug those values from the question into the Pythagorean theorem, and we'll get c squared at the very least. So let's start there and let's see what happens.
Oh, I'm already a step ahead.
Yeah. So you're already squaring at 4, right?
Yeah.
Yeah.
We can do just the 16.
Yeah, because that's 4 squared.
Yeah. And then 25 is 5 squared.
It's 5 squared. Yep. We're good.
And then C would be, if I can get it.
I would just
41.
leave that, honestly, like right now, I would just leave that as c squared.
Yeah.
I would just leave that as c squared. I'll show you why here in just a moment. Because we don't know what c is yet, but we know what c squared is going to be 16 plus 25. But what's 16 plus 25? Let's calculate that.
41.
I don't think that's right. Double check that on your calculator. And this is where, again, the digital SAT, you've got a calculator all the way through. So, that is! You are right, dude! I was looking for something else. You are right. That's so funny, man. I was just expecting to see like 36 for some inexplicable reason, mostly because I'm sleep deprived, probably. Haven't had enough coffee today. But that I'm going to leave this in the recording because, like, just point out, like, if you're unsure about the arithmetic at all, you've got that calculator, man. Like, don't hesitate to use it. Good heavens. All right. So c squared is 41. So what's c? Do you know how to calculate c here at this point?
Yeah. Square root of 41.
Take the square root of both sides, right? And that'll kind of cancel out the exponent there. So c is the square root of 41. So we've just got to pick the right answer that gives us the square root of 41. Does that make some sense?
Yeah.
What's the right answer here, by the way?
D.
Yeah, it's got to be D, right? Which is basically the calculation we just did. Does that make some sense?
Mm-hmm.
Yeah. So if you're familiar with the Pythagorean theorem, you can totally use that here. That works well. It's funny. I was thinking about like another way to solve this right now. I wonder if there's a way to solve this by like just drawing this thing to scale. You know what I'm saying? Like drawing this triangle and see if we can estimate. In fact, I want to consider that as well because maybe you're not so familiar with the Pythagorean theorem if you're watching this recording. I work with a lot of students that aren't. And you got a reasonable shot at like guessing well if you can draw this to scale and estimate. So I'm going to do that real quick. So the A value is 4. I'm going to use these blocks here sort of on the whiteboard. It's sort of like 4 units. There's 4 of the big squares there. The B value is 5. So I'm going to try and make that 5 big squares across. Okay. Again, it doesn't have to be perfect here, but the more we can draw it to scale, the better. And then that's, I'm going to connect those. And then there's our C value right there. Okay. Let me label those values as well. That's 4 and that's 5. So don't worry about, I know you know the answer is the square root of 41. You know, we know its answer is D, but if you're just estimating here, right, is it obvious that C value has to be bigger than 5? Is that obvious to you?
Yeah.
Because we know what 5 looks like. I mean, this is what 5 looks like right here. So I'm guessing it's like, I don't know, 7 or something like that, maybe 6, something around there. You know, does that make some sense? How we can sort of estimate the C value?
Yeah.
Yeah. So I'd look for an answer choice that gives us something close to 6 or 7. Answer choice A is going to give us 9. That's probably too big. I don't think the C value just doesn't look like 9. Does that make sense? How you use in visual estimation, you can eliminate A.
Yeah.
Yeah. It's just not that big. B would give us, let's see, that's the square root of 20. I don't even know what the square root of 20 is. Do you know what it is? We can calculate it.
10-ish?
Well, that'd be 20 divided by 2. I'm just punching it into the calculator. Let's use that magic calculator, man. That's like 4.5 roughly.
4.
Yeah. And it's got to be bigger than 5. So answer is B doesn't make sense visually if we draw it to scale. Does that make sense?
Yeah.
C's even sillier. What would C be if we calculate that? You know the square root of 9, right?
3.
Yeah, it's just 3. It's not 3. Come on, that would be the smallest side. That doesn't make any sense. And at least D gives us something reasonable. I want to calculate the square root of 41. I'm just going to punch that into the calculator. Let's see what we get because I don't know offhand. Yeah. I'll get like 6.4.
Yeah.
For C, right? Which makes sense visually, right? It's got to be something bigger than 5. I said just looking at it, it's like between 6 and 7. 6.4 would be the closest. So there's a path there too if you can sort of draw it to scale and make a reasonable estimate. Questions about that?
No.
Lots of options. There's so many ways to solve these questions, dude. So many ways. And I like that second way. I really do, especially if you're not super familiar with the Pythagorean theorem. So, all right. But there, once again, on the digital SAT, we're seeing more and more questions where they don't give you a figure drawn to scale. On the original SAT, you saw more of those. A lot less on the digital SAT. I'm going to zoom in a little bit. All right. Go ahead and read question number 6 for us. Oh, this looks like a breeze.
4x plus 5 equals 165. Wow. What is the solution to the given equation?
Dude, this is like first week of Algebra 1 here, right? Like this is real basic, right? We can just I'd solve this algebraically. I wouldn't plug in values here. Let's go through the process here. Let's solve for 4x plus 5 equals 165. Can I see you work this out here on the whiteboard?
Yeah.
Yeah, let's just isolate x.
Yeah, it's minus 5 from both sides.
Yeah, absolutely. Golden rule of algebra again. Whatever you do to one side, you got to do the other side.
Yeah. So then we're left with 4x.
Looking good, looking good.
Equals 160.
Oh, yeah.
And divide by
Beautiful.
4.
Beautiful.
And that is going to be x equals, that is a bad x.
I got you.
Equals 40.
There you go. Now, this is a write-in question, right? So you've got to like write in and bubble in, 40. If this were multiple choice, right, we'd just plug in the values for x. That'd be maybe even easier. But the algebra on this is so straightforward. This is just not too difficult. If you've taken Algebra 1, you should be familiar with this. You got any questions about this, Tanner?
No.
Okay. They're giving us some softballs here in this Module 2 at the beginning. Again, there's some tougher ones coming up toward the end. We'll get to those eventually. But that one's no problem. This one's a little trickier looking, at least. But I think it's pretty straightforward if you understand what the question's asking. Go ahead and read question number 7 for us, please.
The x-intercept of the graph shown as x equals x0. What is the value of x?
That's funny. I'm looking at this now and I'm wondering. I think they actually give us some answer choices here on this question. I'm going to look at this real quick on the practice test. I've got it. This is question number 7.
Yeah.
Yeah, I think I forgot. Oh, no, this is not. This is a write-in. Okay. So they don't give us answer choices. This is right. What are we solving for here with this question?
The value of x.
Yeah, we're solving for the value of x. And they say the x-intercept of the graph is this point x, 0. Okay. Now, you should be able to look at this and just like find the x-intercept of this graph. Do you know what x-intercept means?
Yeah.
What does that mean?
Where it intercepts the x-axis.
Yeah, we're the line, or in this case, it's a parabola, but it doesn't matter. We're the line or the parabola intercepts or touches the x-axis. You should be able to circle that point where the parabola touches the x-axis. Can you show me that? Just circle it. Yeah, right there. Okay, and that's the point x, 0. So what's the value of x?
0.
No, the value of x is not 0 there. The value of y is 0 at that point. What's the value of x? Maybe let's step back. I mean, we are solving for the value of x, but let me ask you another question. What's that point right there? Could you tell me what that point is in terms of x and y?
Oh, it's 7.
That's 7, 0. Does that make some sense? That's 7, 0. Yeah, I mean, we could, count. They give us the units, that's 1, 2, 3, 4, 5, 6, 7. That's 7 units away from 0 on the x-axis. That's the point, 7, 0. So if that point could be described as x, 0, then x is 7. Does that make some sense?
Yeah.
A little bit tricky there, right? You were answering what's the value of y. Yeah, the value of y is 0 there, but the value of x is 7. It's a little tricky keeping your x and y values straight sometimes. It is, but it's really just a question of being able to draw that information out from the graph. Any questions about that, or does that make some sense?
That makes sense.
Yeah, 7 is our answer. But easy to get tripped up there if you can't keep those straight. But we'll see lots more graphing questions, and we'll practice drawing out that information from the graph. All right. Most questions I've seen like that on the SAT they'll give you multiple answer choices. That's funny. That's a write-in one where you got to figure that out. All right, go and read question number 8 for us, please.
The function f is defined by f of x equals 1 over 10x minus 2. What is the y-intercept of the graph of y equals f of x if the xy in the xy plane?
Yeah. Ooh, what are we solving for here, Tanner?
We are solving for the y-intercept.
Yeah, we're solving for the y-intercept of this graph. Yeah. A couple ways to think about this question. First of all, let's talk about what y-intercept means. What is the y-intercept? What's that mean?
Where it intercepts on the y-intercept.
Yeah, it's where the line intercepts or touches the y-axis. That's it. Okay. Now, if you're familiar with y equals mx plus b form, are you familiar with y equals mx plus b form?
I think so, yeah.
Yeah. And we're going to talk about that here in just a minute in more detail. that's one way to think about it. If you know what that means in y equals mx plus b form, you can sort of draw out the slope and the y-intercept. If you have an equation that's in that form, you can draw that out. Another way to think about it as well is I've got a section on the rules. In fact, I want to go to this section on the rules that covers this concept. So let's go to that rules document. And I want to go to basic concept D. That's graphing.
Yeah.
Okay. And I want to go to what bullet point is this? 1, 2, 3, 4, 5, 6. The seventh bullet point says the y value at the x-intercept.
Yeah.
Yeah. This is a concept I've seen tested in a lot of different ways in a lot of different questions, but it's an important concept to know. I want you to read that seventh bullet point on graphing. A lot of graphing questions, a lot of graphing concepts here. Read that bullet point for us, please.
The y value at the x-intercept is always 0, and the x value at the y-intercept is always 0.
Yeah. Does that concept make some sense why the y value at the x-intercept is always 0? In fact, we just saw a question that covered that concept, right? Remember where that parabola was touching the x-axis, the y value was 0, but the x value was 7, right? Does that make some sense?
Yeah.
Yeah. And then the x value at the y-intercept is always 0, which should make sense. I mean, if you look at a graph, I'm going to draw a little graph, little xy axis just to the right of the question here. And if you draw any line, doesn't matter what it is. Like there's a line right there. Here's the y-intercept. What's the x value at that point? The x value.
X value 0.
Is 0. Always. Doesn't matter what line you draw. You draw another line here. The x value at the y-intercept there is also 0. Okay. And if you give us the graph, if they give us the graph, we could just kind of look at it and figure out what the y-intercept is. But they just give us the equation here. But it doesn't matter because we know we can plug in a 0 for x into this equation, and that will give us the y-intercept. Does that make some sense?
Yeah.
Yeah. So let's do that. Let's plug in a 0 for x into the function. I think we worked on functions a little bit previously in the Module 1 recordings.
Yeah.
But basically, we're just going to find f of 0, right? Because x is 0 in this case. I'm going to plug that in. We get 1/10 times 0 equals, minus 2. And what's that going to equal?
Minus 2.
It's going to equal negative 2. So the y value, remember, f of x is just fancy y.
Yeah.
The y value is negative 2. So we just got to pick the answer that gives us a negative 2 for y in the answer choices. And what's the right answer here?
B.
It's got to be B, and it is. Yeah, just by plugging in a 0 for x. If you know that the x value is 0 at the y-intercept, that should eliminate answer choice A. It does. Then you're left with just C and D, but then just plug that 0 into the function and find out what your y value is when x is 0. And it gives the answer choice B. I want to go back to that y equals mx plus b form real quick, and I want to interpret this now. Okay? Let's talk about, first let's talk about the m value in y equals mx plus b. What does the m value represent? Are you familiar with that? And you can say no if you don't know.
I forget.
Yeah, that's okay. That's okay. Yeah. The m value is the slope of the line.
Oh, yeah.
Okay. Which you can also understand as the rise over the run. Mm-hmm. Right? Count how much you're going up, count how much you're going over. You've got the slope, rise over the run. Does that make some sense?
Yeah.
Yeah. And then the b value in y equals mx plus b form is what? What's the b value?
Can you remind me?
Yeah, it's the y-intercept.
Ah.
Yeah. So if you've got an equation in y equals mx plus b form, which we have here, you should be able to look at this and just tell me what the b value is. Tell me what the y-intercept is. Do you see it now looking at the equation?
Yeah.
Yeah. I mean, it's negative 2. That's your y-intercept. So just pick the answer choice that gives you a y value of negative 2. If you can interpret y equals mx plus b form. Does that make sense?
Yeah. Mm-hmm.
Or you can just be like, hey, the x value at the y-intercept is always 0. But that's why it works, right? Because if you plug in a 0 for x, all you're left with is the b value. All you're left with is negative 2 when x is 0. That's why it works. Does that make some sense?
Yeah.
A couple ways to interpret that, but that's not too bad. Questions about that?
No.
Okay. And if you see a question, you're working on this, just go to the rules document, and I think the second bullet point for basic concept degraphing I help you interpret y equals mx plus b form. M is the slope, rise over the run, b is the y-intercept. That's all there. So knowing that is pretty handy on the SAT. So know it. All right. Let's see what's coming up next. I have no idea. Find out together. Ah! This is kind of a scary looking question. Go and read question number 9. We're going to break this down together.
And the function f is defined by f of x equals 7x to the third power. In the xy plane, the graph of y equals g of x is the result of shifting the graph of y equals f of x down 2 units, which equation defines function g.
Oh my goodness. What are we solving for here, Tanner?
The equation that defines function g.
Yeah, function g, which is a result of shifting the graph y equals f of x, basically this function up here.
Yeah.
Shifting that down 2 units. So the question is, what is g, which would be f of x, or f, shifted down 2 units? Does that question make a little sense? I'm not saying you know how to solve it just yet, but does the question make sense?
Yeah.
Okay. Let's talk about shifting lines here, sort of, on an XY axis and what that means and what that looks like. So let's just kind of wrap our heads around this first. I'm gonna draw a little XY axis just to the right of the question. Nice wobbly little XY axis there. That'll work. And then I'm going to draw a line. I'm going to give it a slope of 1/2 here. Oops. There we go. Something like that. Okay. There's a line. So that would be, the slope is 1/2 there because I'm going up 1 over 2. Is that clear?
Yeah.
From one point to the next, we're going up 1 over 2. So the equation of this graph would be y equals 1/2 x. And then what's the y-intercept of this line? You should just be able to look at it and tell me where's the line hit the y-axis.
It's right here.
Yeah. And what's the y value there at that point?
It is 3.
3, yeah. So the equation is y equals 1/2 x plus 3. Remember, because that b value in y equals mx plus b form is your y-intercept. Does that make some sense why that's the equation of that line?
Yeah.
Okay, good. Now, if we were going to shift that down 2 units, okay, we're not changing the slope. It's just like dropping that thing down. Like all the values, the rest of the values are going to be the same, except everything's dropped down 2 units. So it'd kind of create a parallel line. I'm just going to drop that y-intercept down 2 units. We'll start there. But it's the same slope of 1/2. So it looks something like that. Does that make some sense?
Yeah.
Yeah. What's the equation of that line in blue? Could you tell me what the equation of that line in blue is? Can you hear me, Tanner?
Yeah.
Yeah.
Sorry,
I think we cut out for just a minute. Yeah. What's the equation of that line in blue?
The line in blue would be.
It's the same slope. Slope is 1/2.
Yeah, so it would be 1/2 x plus 1.
Plus 1. Right? Which shouldn't surprise you because I'm dropping all the values basically 2 units. Right? Then that b value, the y-intercept, is also going to go down by 2 units. It's going to go from 3 to 1. Basically subtracting 2 from the b value. Does that make some sense?
Yeah.
Yeah. So this question is very similar. Right? It looks scary because like we're raising like x to the power of 3. So it looks kind of terrifying, but it works the same way. We just are basically changing the y-intercept. I mean, all the values, including the y-intercept. We're just dropping them down 2 units. Is all we're doing. So like if we had a parabola, let me erase this here. If we had a parabola, something like this. Woo. If that were the line y equals x squared, if I'm dropping that down 2 units, I'm just basically changing the b value at the end I'm just subtracting 2. And it would look something like this. Does that make some sense? Just a rough sketch. Yeah. So, do you think you see the right answer here?
Yeah.
What's the right answer?
Would it be C?
It's not C. That would be
D.
It's got to be D. Yes. Do you see why it's D?
Yeah.
Yeah, because that's subtracting 2 units from the original function. If we're dropping it. If it were going up 2 units instead of down, if it were going up, then it would be answer choice C. Does that make some sense why that would work?
Yeah.
You're just taking all the same values and adding 2 for answer choice C, taking all the same values and subtracting 2 for answer choice D. And I've added this to the digital SAT rules. Should be basic concept D graphing as well. Let me see here. There we go. This is bullet point number 6 on basic concept D. I want you to read that for us here. I haven't seen any shifting of lines questions on the original SAT, but I'm seeing them now here on the digital SAT. So I want you to read that 6th bullet point for us, please.
Yep. For the line y equals 2x plus 5 shifted down 4 units, and new line is y equals 2x plus 1.
I'm going to stop you real quick. Does it make sense why we're basically subtracting 4 from the b value in that equation? The line y equals 2x plus 5, yeah. If it's going down. Keep reading, please.
If the line is shifted up by 4 units, the new line is y equals 2x plus 9.
Yeah, so if you're going up 4 units, you're basically adding 4 to the b value, y equals mx plus b form. But even if it's a parabola, or like, I think if it's raised to the power of 3 like it is here in this question, it's going to be like a weird squiggly. It's the same concept. You're just adding or subtracting, adding if you're shifting up or subtracting if you're shifting down. Questions about that?
No.
Okay. Not like a real specific operation here or anything like that. It's just sort of understanding what things mean there in that question. All right, go and read question number 10 for us, please.
X plus 7 equals 10. X plus 7 to the second power equals y. Which ordered pair x and y is a solution to the given system of equations?
What are we solving for here, Tanner?
Which ordered pair is the solution?
Yeah, which ordered pair is the solution to these systems of equations? We've got another systems of equations question. We've seen a number of them so far just on this second module here on SAT Practice Test 1. Digital SAT Practice Test 1. We've got some options here. I mean, we could just plug in these answers, right, and see which answer choice gives us a true statement. Is that sort of obvious why that would work? It's not a bad place to start, But notice the first equation here just gives us the x and y values.
Yeah.
Or just gives us the x values, I should say. Just the x values. And if you look at the answer choices, right, like all of the answer choices give us a 3 for x, right? Do you see that?
Yeah.
So we can't just plug into the top equation here. It'd probably be better off plugging into the bottom equation for all these.
Yeah.
So, I don't know. Let's plug them in and see what happens.
Okay.
So plug in the answer choices here to the bottom equation. One of these, the right answer, should give us a true statement.
Me at the parentheses.
Yep.
Second power. 10 to the second is 100.
So is that a true statement?
Yes.
Yeah, it is, right? I mean, that looks pretty good. I'm going to double check the answer. Yeah, that is A. I think we found it. I don't think we need to plug in the others. That's it. The others just wouldn't give you true statements here. So that's not bad, is it?
No.
Yeah. No, that's just arithmetic. There's an algebraic way to do this too. It's really not bad because we know what x plus 7 is, right? X plus 7 is 10. They tell us that, so we can literally just replace x plus 7 here in this equation with 10. We get 10 squared equals y. What's 10 squared? Well, you already
10
told me.
squared is 100.
Yeah, 10 squared is 100, so the y value has to be 100, so it's got to be A. The algebra is not bad either. In a sense, this is a substitution question. We can substitute for x plus 7. Just plug in that 10, and that works. We could solve for x as well. Again, we know x is going to be 3. There's no way around it. But plugging in is pretty easy there. Any questions about that?
No.
That's just not bad. I mean, it's really not. I'm seeing, the digital SAT so far, I'm seeing, the questions tend to be a little easier. Now, if you do really well on Module 1, will they give you more difficult questions on Module 2? I think that's very likely. I do, but I'm looking at the scoring scale so far I've seen. I was looking at it this morning, in fact, prepping for this. And there's a little less room for error on the digital SAT. Yeah, questions are easier in general. There's some tough ones at the end, there are. But you got to be really accurate here on these easier questions. Can't rush through them and make silly mistakes. But they're just giving you points here. I mean, if you can think about it clearly, this is a breeze. All right. Let's look at question number 11. Going to read question number 11 for us, please.
Which expression is equivalent to 7x to the third power?
Yeah, you don't need to read to that. Yeah, what's equivalent to that big mess right there? Woo! What does equivalent mean, Tanner? I think we've seen a question like this before. What's equivalent mean?
The same.
Yeah, it's same, equal to, all that. So we've got options here. We can kind of combine like terms. If you're familiar with doing that, I think we saw some combined like terms questions when we were working on Module 1 together. We can also plug in a value here, which I think is probably the easiest way to do it. Especially if you get tripped up easily on combining like terms. I want to start there, just because it works really well here on this question. I want to create a value for x. We're going to make x equal 1. If we're plugging in a 2 or 3 for x, we're just going to get bigger values. The arithmetic's going to get more complicated. So I think here it's worth just starting with 1, seeing if that works. And I think it will here. If x is 1, what is the expression in the question equal, right? And this is sort of the path, right? Is we have to figure out what this expression equals when x is 1, and the right answer choice will equal what that expression equals when x is 1 as well. So we're going to have to calculate that. Can I see you plug in a 1 for x into this expression in the question, and we'll simplify it together?
Yeah.
Yeah, let me see you do that.
But at the end of the day, it's all going to be just removing the x.
Yeah, right. And it's kind of obvious. In fact, if you want to do that right now, like 1 to the power of 3 is just 1, and 7 times 1 is just 7. So like the x's are basically going to disappear. We're just left with the coefficients in front of the x terms. So yeah, dude, go ahead. Please do. We've talked about it before. Yeah. That's the beauty of plugging in ones. If you plug in a 0, right, basically everything would become 0 here. But I guess all the answers would be 0 as well. So that's why I think plugging in 1 makes more sense. Yes, don't forget those parentheses. That's important. That's really, really important. Okay, good. Let's simplify this. Yeah, we're just going to PEMDAS this, right? Calculate what's inside the parentheses. This is perfect. Love it. Yeah. What's 14 minus 3, Tanner? Use that calculator. 11. Don't make the mistake I made earlier. There you go. It's 11. Yes. All right. So the right answer has to give us 11 when x equals 1. Does that make some sense, Tanner?
Yeah.
Yeah. Okay. So we're looking for 11 when x is 1. Let's look at these answer choices. I'll bet we don't even have to work this out. I'll bet we can just calculate, right? When you know that, what is answer choice A going to equal when x is 1? I'll bet you can just tell me.
It is going to equal 10.
Oh, well, maybe we do need to work this 11. Out. Yeah.
Yeah.
What? Remember, we were just talking about what's 1 to the power of 3 equal?
1.
1. So that's 1 plus 10 times 1. Of course, 10 times 1 is 10. So it's 1 plus 10. What's that equal?
11.
That equals 11. Does that make sense?
Yeah.
And it's tricky, right? Because earlier we were saying if you plug in a 1, the x's disappear, which is true if we're multiplying, because anything times 1 is itself, so we're just left with the coefficients. But if it's just x or x to the power of 2 or x to the power of 3, that's still going to be 1. It doesn't disappear exactly. It'd only disappear if x was 0. Okay, so that's 11. That's looking good. Let's look at the other answer choices. What is answer choice B going to equal?
B is going to equal...
should just be negative 13 plus 10.
Yeah, negative 3.
That's going to be negative 3. That's not right. What's answer choice C equal?
Negative 9.
Negative 9. That ain't right. What about answer choice D?
5.
That's going to be 5. So it's got to be A. Whee! And it is, I think. Let me double check. Yeah, it is A. Questions about that?
No.
Hey, plugging in the values. Really made that relatively easy. You can keep your arithmetic straight. Let's talk about combining like terms, right? Because that's another path too. And like, I go back and forth. I mean, if I were seeing this question for the first time, I don't know. I mean, the combining like terms is not too difficult. I think most students are familiar with that. But if you're not familiar with it at all, then of course, just plug in the values is going to be the best path. But let's talk about combining the like terms here, because I don't think it's too tough. Before we combine like terms, I would probably distribute that negative sign right here to the terms in parentheses on the right-hand side. Does that make sense why we have to distribute that negative sign?
Yeah.
Because we're subtracting all of that stuff in parentheses. We're subtracting 6 times x to the power of 3, and we're subtracting, minus 3x. So we need to distribute that negative sign. So let me start. I'm just going to copy the expression. I mean, the left-hand side stays the same. So we're going to get 7x to the power of 3 plus 7x. And then what do we get next if we distribute that negative sign in the expression? What do we get next, Tanner? You just tell me and I'll write it down. Do you understand my question?
I think
if we distribute that negative sign, basically we're flipping the signs of the terms in parentheses here.
So we're going to have a 6x to the third plus 3x.
Well, negative 6x to the power of 3.
Oh.
Because we got to flip that sign, right? It's positive in the parentheses right now. Does that make some sense?
Oh, yeah.
Yeah, it's not negative yet. I mean, we're subtracting all that stuff, but I think I see when I said flip the signs, it looks like negative 6x. It's going to be, but right now it's positive. Is that clear?
Yeah.
Yeah. And then flip the sign to the 3x, or negative 3x becomes positive. Does that make sense why that's what we get?
Yeah.
Okay. Now, when you combine like terms, I really recommend underlining the terms that are like. And when I say like terms, like you've got the same variable raised to the same power. Basically, it's got to match exactly. So let's start there. Let me see you underline 2 terms that are like. I think we've got 2 pairs of 2 terms, but just start with underlining the 2 terms you're going to combine. We'll talk about what that process looks like. Now, this is interesting, right? This is interesting. Those aren't actually like terms. You might be like, well, they both have 7s in it. It's like, okay, yeah, the coefficients are like, but the variables aren't. Yes, those are your like terms. And I'm going to actually extend that black line here. Yes, you've got it now. Those are your like terms. The 7x to the power of 3 and the negative 6x to the power of 3 are your like terms there. Yeah. Does that make some sense? Yeah. Mm-hmm. So let's start with these 2 terms here. You can't forget about that negative either. What do you get when you combine those like terms? What do you get?
A 1x.
You get 1x to the power to the third power. Yeah, the variables stay the same there. But 1x to the third power is just the same as x to the third power. Does that make some sense?
Mm-hmm.
Yeah. So we'll just say x to the power of 3. And then let's combine these other 2 terms. We've got positive 7x and positive 3x. What do we get there when we combine those?
10x.
Plus 10x. What's the right answer?
The right answer is A.
It's A. There it is. That's not too bad. But I see students make some silly operational errors with combining like terms, and that could be a factor here, potentially. So you've got some options. If you're really comfortable with it, go and do the algebra. I probably would, seeing this question for the first time. But you can also plug in values the way we started with as well. And that works too. The more tools you have in your toolkit, the better chance you have of finding the right answer. So, any questions about that, Tanner?
No.
Okay. Look at question number 12. Go and read 12 for us, please, Tanner.
The function p is defined by p of n equals 7n to the third power. What is the value of n when p of n is equal to 56?
Oh, what are we solving for, Tanner?
The value of n.
The value of n. Yes, when p of n is equal to 56. Okay. Do you understand what that question is asking us, or maybe not so much?
Yeah.
Yeah. Yeah. A lot of students struggle with understanding, interpreting sort of function notation. But all this question is saying for anybody watching the recording where it isn't clear, the p of n value, and that's like your output or your y value basically in a function, is 56. So we can literally replace p of n with 56. Does that make some sense? Why we can do that? Yeah. So like we could sort of rewrite this expression. It's probably a good place to start. I think it's easier to wrap your head around. Yeah, go and do it, Tanner. You got it. So literally, you got it. So replace p of n with 56. We'll write the equation out. And then we're just solving for n. Now, it's a little tricky here, right, doing the algebra because, we're raising n to the power of 3. There's a specific operation. We can talk about that here in just a minute. But look at the answer choices, right? The question is, what's the value of n? So, like, we should just be able to plug in these answer choices for n into the equation, and the right answer should give us a true statement for those values of n. These are all your n values here. Does that make some sense? Why you can just plug those in?
Yeah.
That's probably the safer path. We can talk about the algebra here in just a minute, but I think I just plug those in. So plug in a 2 for n. Let me see you plug in a 2 for n. We'll start there. Let's see if that gives us a true statement here. I'm going to add those parentheses. I think it's just a good habit dealing with parentheses. Yep. Well, 7 times 8?
56.
56. Hey, look, that works. Hold on. Let me check the answers. Yeah, 12, I think we found our answer. 12 is A. That's not bad, man. That's not bad. I mean, it's helpful that it's A there and we don't have to go through A, B, C, and D and be like, okay, D works finally. But the others just aren't going to work. It's going to be way too big on the right-hand side for C and D. Questions about that? Does that make some sense?
That makes sense.
Yeah. If you wanted to solve it algebraically, boy, I don't think I'd recommend it, but you could. And it might be helpful on some other questions, maybe some others that we're seeing coming up here in just a moment. If we want to solve for n algebraically, like isolating n, do you know how to do that here? How to isolate n in that equation?
Yeah.
Yeah.
I think
where would
maybe.
you start? Where would you start?
Could you remind me?
Yeah, I mean, like, the scary part is that n to the power of 3, right? It's kind of scary looking. But at the very least, I would start, we see n to the power of 3 is being multiplied by 7. So I just start by doing the opposite of multiplying by 7. What's the opposite of multiplying by 7?
Divide.
Divide by 7 on both sides. So I'd start there, divide both sides by 7. Does that make some sense?
Yeah.
And so that's going to cancel out. So that's going to give us n to the power of 3 equals, well, whatever 56 divided by 7 is. I mean, I'm going to have to punch that into the calculator. I'm guessing I'll get a big decimal. Oh, no. Boy, my arithmetic is off. That's 8. So funny. My arithmetic is way off today. You've got the calculator all the way through the digital SAT. Good heavens. That's good news, man. That's good news. I hope it's anybody watching the recording, I'm totally leaving this in. It's like, I'm not a math genius. I'm not a math whiz. I've got 6 kids. I'm mildly sleep deprived. And, I'm just not. But if you can think about the questions clearly, you don't have to be perfect. You don't have to know everything for this test. You just have to know enough to find the right answer. And anyway, I'm not a math teacher. I taught history for 11 years in the classroom. Good heavens, so. But it's all about clarity of thought and logic. So you don't have to be an expert. You don't have to know everything. All right. And then now this is tricky though too, right? Because we get 8 equals n to the power of 3 at that point. And then how do you solve for n? Sort of algebraically, how do you isolate n? Do you know what the operation is here, Tanner, or no?
I don't know the operation.
So remember when we got, remember we're doing that Pythagorean theorem question and we got like 41 equals c squared. Remember that?
Yeah.
And that geometry question we were just doing. What did we do to both sides to get c alone? What did we do?
Oh, man, I forget.
Yeah. We took the square root of both sides.
All right.
Right? Because the square root is going to cancel out that exponent, basically. And we get c equal the square root of 41. Now, here we don't have a square root. We have a cubed root. Well, sorry, n to the power of 3, I should say. N is cubed. So instead of taking the square root, if we take the cubed root of both sides, you know what cubed root means? No. So cubed root, it's funny. It means there's some number times itself 3 times. That gives you 8. That's what the cubed root means. Okay. When it was just a square root, like the square root of 9 is 3 because there's some number times itself 2 times. That gives you 9. Square root of 16 is 4 because there's some number times itself twice, or times itself. That gives you 16. But here, there's some number times itself 3 times. That gives you 8. That number is 2. Does that make sense? Why 2 times 2 times 2 gives you 8?
Yeah.
Let's talk about cubed roots a little bit more. The cubed root of 27. Do you know what the cubed root of 27 is? There's some number times itself 3 times. It gives you 27.
7.
Not 7.
Oh. 9.
Well, the square... sorry, hold on. The square root of 81 is 9. But, punch that in your calculator real quick. Do you know how to do a cubed root on your calculator? Or no?
No.
Yeah. There's I've got there should be a function on, any scientific calculator. I've got one on my phone. There's a way to punch it in. Boy, just do a YouTube search if you don't know how to do cubed roots do you have an iPhone by any chance?
Yeah.
Yeah, you should go to the scientific calculator function. Actually, there's a cubed root button. I see it right now. You'll see it's X underneath the root sign, and then there's a 3 right next to it. It's right there. Do you see it?
Yeah.
Yeah. So literally just punch in 27 and then cubed root.
Oh, 3.
It's 3. Which should make sense, right? Because 3 multiplied by itself 3 times gives you 27.
Yeah.
3 times 3 is 9, times 3 is 27. There you go. So that's right. Again, if you know how to use that calculator, boy, if you don't, figure it out. But you know how to use that calculator, they give you access to an online, basically it's a form of the Desmos calculator. Are you familiar with the Desmos calculator at all?
I think so, yeah.
Yeah, it's like an online graphing calculator. A lot of students use that in their math classes. So you've got some limited functions on it, but you should have the cubed root or any root. You should be able to use that function. So that's an option there. But again, you don't even have to go there. Maybe I should have even shown you guys. I don't know. Because the easier path is just plugging in the values. And then you're just doing the arithmetic instead of doing the right operations. So I like that first way of going over it. Any questions there, Tanner, about that?
No.
All right. Let's do question 13 here. Oh, we got some more geometry not drawn to scale. Just go ahead and jump right into the question here for us, please.
If the figure shown line C intercepts parallel line S and T, what is the value of X?
What are we solving for in this question, Tanner?
The value of X based off of the 110 on T.
Yeah, we're solving for the value of X, which is the degrees here of that angle right there in the figure. Now, of course, again, we've seen this already on this module that the figure's not drawn to scale. Yeah. Now, you've already got the answer, but you know how this stuff works, right?
Yeah.
I mean, I'll tell you right. I mean, the answer is going to be 70. Let me explain why that's the case here. First, to anybody watching the recording, we should be able to figure out what the value of that angle is right there, right? And which you already got.
Yeah.
Right? Every straight line is 180 degrees. So you're already doing this, dude. You've got every straight line is 180 degrees. So that angle in green has to add with 110 to give you 180. So we know that angle in green is 70 degrees. Does that make some sense?
Yeah.
Yeah. Then it's okay, well, what's X degrees equal. Well, I know the figure's not drawn to scale, and I know that angle right there just really doesn't look like 70. It doesn't. It looks more like 45 or something like that.
Yeah.
So that's why it's not drawn to scale. But there's another angle that looks just like that one, which is x degrees. So you'd be like, well, x looks like it's 70 if this angle here is 70. That could give it to you. There's something else. It's called the alternate interior angles theorem. Are you familiar with this? Alternate interior angles. Is that familiar?
Yeah.
I want to go to the rules because they don't give you this, formula or this concept here. But I give it to you on my rules document, so I want to go to that real quick. I've just added it because I haven't seen it tested where you need it much on the older version of the SAT, but you need it here. This is basic concept of V. Basic concept of V on my rules document. So it's all the way at the bottom. I've sort of just added it. I don't want you to add that. I just tossed in this picture I found here online. Go ahead and read the alternate interior angles description here.
Alternate angles are angles that occur on opposite sides of the transversal line that are the same size.
Yeah. So look at that. Look at the examples here I give you with that angle A that's sort of in red here. And at the transversal line, that's the line that's sort of crossing through or going across two parallel lines. That's the transversal line. That's worth knowing. I haven't seen that term transversal pop up in the SAT, but it's going to make sense sort of this description of alternate angles. So if you know that angle A, then the alternate angle on the opposite side of that transversal line is also A degrees, which means that this angle up here right across from the top angle A is also going to be A degrees because of vertical angles. Are you familiar with vertical angles? Have you heard that term before? Vertical angles?
Yeah.
Yeah. Basically, you have two straight lines, the angles opposite each other on, where two straight lines cross are equal. So this guy up here is also A degrees. And then, this guy right here is equal to this guy down here. So those are vertical angles. So going back to the question, we can identify that this here is 70 degrees as well. And because those are vertical angles, these guys right here, X has to be 70 degrees. But I think once you identify that this is 70 here, you can just be like, well, X looks like that same angle, so 70. Does that make some sense?
Yeah.
Yeah, you got the answer right off the bat, just looking at it sort of instinctively. So really, really good job there, Tanner. But you can't use visual estimation here. You can't because it's not drawn to scale, So I think just knowing that alternate interior angles theorem, I think is going to be helpful. Questions about that?
No.
Okay, you're doing great. Great job there. All right, let's take a look at question number 14. I'm going to increase the size of this question here a little bit. Go ahead and read number 14 for us, please.
A list of 10 data values are shown. What is the mean or the average of the data?
Yes, I love the way you read that, right? Just knowing that mean means average. And that's sort of like classic average, right? Do you know how to calculate the mean or the mean average? Same thing?
Yeah.
Yeah.
You have to add up all the total values and then divide it by how many values.
There you go. Add up all the values, divide by the number of values. I think most students are pretty familiar with this. I just want to point this out where I've got it on my rules document. I want to go to basic concept I real quick, just in case you see this term and you're not familiar with the definition. But there's other forms of averages, including median and mode, that are worth knowing. So this basic concept I, statistics. I want you to read that second bullet point where I kind of talk about some of these common terms.
Mean equals the classic average. Median equals middle number. Mode equals most frequent number or occurring number. Range equals difference between highest and lowest number.
Yeah, the only one we have to worry about here is the mean, the classic average, but the others could pop up in some other questions, so I want to show you where that is on the rules document. So let's just it's just running the calculation. Honestly, you can even just do this on your calculator. I think the trickiest part about this question, if you know what mean means, trickiest part is just not messing up something when you're punching it in. But we're just adding all those up.
Yeah.
6 plus 8 plus 16 plus 4.
The mean is going to be 10.
26. I'm still doing it here on my end. Trying not to mess up anything as I punch it in. There you go. Yeah. And then we've got 10 values. There you go. The answer is 10. You beat me to it, man. Really good job there. Answer is 10. It's a right in there. But this question really just kind of hinges on knowing the definition of mean. Just means average. Be aware of that. Sometimes they'll say mean average as well, or mean arithmetic average, or arithmetic mean. I've seen that as well on some other questions. It's all the same thing. Questions about that, Tanner?
No.
Okay, great job. All right. All right, this is a little scarier looking here. Go ahead and read question number 15 for us, please.
15. The equation E of t equals 5 multiplied by 1.8 to the unknown power gives the estimated number of employees at a restaurant, where t is the number of years since the restaurant opened. Which of the following is the best interpretation of the number 5 in the constant?
Ooh, what are we solving for here?
The best interpretation of 5 in the
the best interpretation of the number 5. I want to take a look at this equation here, this function E of t. Is it obvious to you, just sort of by looking at that function, that equation, what 5 means in that equation? Do you have any idea?
Possibly the number of employees at the time of when it opened, or at the moment.
Yeah. Why do you say that? I think I agree with you. Why do you say that?
Because we have in the parentheses you have 1.8, which could be an estimated time of just a general time, and then you have the
t value is the time. What does the 1.8 represent in the function? It's not the time. Time is t.
Number of years.
It's not the number of years. It's not. Ooh. Yeah, it's not.
Percentage?
It's a percentage increase is what that is. It's a percentage increase. I want to go to the rules document real quick because I've got a section here on percent increase. This is really helpful, I think, here on this question. I think it's basic concept P. It is basic concept P. It's basic concept P. So go down to that. And I want you to read the second bullet point. I've got an example here of percent increase over time. Go and read that second bullet point, please.
Okay, $100 invested at a 7% increase compounded annually is 100 multiplied by 1.07.
Yeah, to the power of t. I think we talked about percents a little bit. I think it was actually on the first question on Module 1 we talked about percents. 7%, is it obvious that 7% is 0.07? Is that sort of obvious? We've talked about that, I think.
Yeah.
To some extent, right? I mean, 7% literally means 7 divided by 100. That's 0.07. So if you want to increase something by 7%, you just multiply by 1.07. If you want to increase it by 7%. Because you multiply by 1, you get the original value, but it's not multiplied by 1. It's 7% more than 1. It'll give you a 7% increase. Okay? So notice the original value is sort of outside the parentheses here, right? If we're talking about $100 invested at a 7% increase. The original value, 100, is outside parentheses. And then in parentheses is your percent increase. In this case, it's a 7% increase. We're multiplying by 1.07. It's not a 107% increase. That's just a 7% increase. Does that make some sense? Yeah. What's kind of funny is that if it were a 0% increase, you'd be multiplying by 1 because anything times 1 is itself. It's not increasing at all. But because it's an increase, we got to be multiplying by something bigger than 1, so it's 1.07. And then the time, of course, is the exponent here. It's raised to the power of t. Notice also we're just raising the 1.07 to the power of t. We're not raising the 100 to the power of t, just the 1.07. Does that make some sense, that expression?
Yeah.
I want to look at the first bullet point as well because, we haven't seen many questions yet. We'll probably see some more coming up on percent increase and decrease. But here I kind of explain how this works as well in the first bullet point. A 25% increase of x is x times 1.25. Does that make some sense why that'll give you a 25% increase of some value, x?
Yeah.
And then a 25% decrease of x. A lot of students think it's x times 0.25, but that'll give you 25% of x if you multiply x by 0.25. If it's a 25% decrease, there's only 75% left. So you got to multiply by 0.75 if it's a 25% decrease. Does that make some sense? Or no? You can say no if that doesn't. That doesn't sound like it makes sense. The decrease. Does the decrease make sense or no? You there, Tanner?
Yeah.
Does that make some sense? I think you were just cutting out for a minute. Does that make some sense or no?
Yeah.
Yeah.
It does.
Okay. If we see a percent decrease question, we'll get into that in more detail. And I think it'll make more sense in the context of another question. But let's go back to this question here. So what's the percent increase going on here? How much is the number of employees increasing every year? You should be able to figure that out.
1.8.
But it's not a 1.8% increase, right? It's not a 1.8% increase. That represents an 80% increase, is what that represents. If you're multiplying by 1.8, it's an 80% increase. I'm going to explain why here in just a moment, but just hold on to that right now. I don't even think you have to know that, right? Because we're focused on what is the meaning of 5 in the question. That's what they're asking, right? And you're 100% right. That's like the original value you're starting with. I mean, what's the answer here?
A.
It's got to be A. It's got to be A. It's the original value, the estimated number of employees when the restaurant opened. Now, we can confirm that here by plugging in some values. I want to show you how that's going to work. If we plug in a 0 for T, now think about what this means. What does it mean when T is 0, Tanner? What's that mean?
That means that there's been 0 years. Right?
Yeah, 0 years since the restaurant opened. Like, no time has passed. It's when the restaurant opened. Does that make some sense?
Yeah.
And if we plug in a 0 for T, we'll get E of 0. And remember, E is the number of employees. E of 0 equals 5 times 1.8 to the power of 0. I don't know if we've talked about this a whole lot yet. Do you know what anything to the power of 0 equals? Do you know what it equals?
It equals itself, right?
No, well, that's anything to the power of 1 is itself, right? X to the power of 1 is
then
X.
it's just 0.
Well, no, anything times 0 is 0, but things to the power of 0. I want you to punch this in your calculator. Do you know how to raise stuff to the power, to powers on your calculator? We were just talking about roots. Yeah. Raise 1.8 to the power of 0. Tell me what you get.
1.
You get 1. Anything to the power of 0 is 1. Anything to the power of 0 is 1. So that just gives us 5 times 1. Does that make some sense? I could get into why stuff to the power of 0 equals 1. I've got that in some other courses and some other recordings. I don't know if I want to get into it right. I mean, I could. I don't know. If anybody's like desperate to know, just shoot me a comment and maybe I'll make a video on why stuff to the power of 0 equals 1. But you know what? No, am I going to show you it right now? No, I'm not going to. I don't want to complicate it too much. Because you can punch it into your calculator on the digital SAT. Just find, don't make a guess. Find out what 1.8 to the power of 0 is. Don't be like me making silly arithmetic errors in this test. Just play it safe. Punch it into the calculator. So when no time has passed, basically the number of employees is going to equal 5. And so we can confirm that's answer choice. That's the meaning of the value 5, the number of employees when the restaurant opened. Does that make sense?
Yeah.
I want to look at the other answer choices real quick. I think they're kind of silly if you really think about this question clearly. Look at answer choice B. Go ahead and read answer choice B for us.
B or B?
Yeah, B. As in boy.
Yeah. The increase in the estimated number of employees each year.
Yeah. But that doesn't make a whole lot of sense, right? You could plug in a 1 and a 2 and see how much it increases. It's not going to increase by 5 every year. It's going to increase by 80%, close to 5. If it were increased by 100%, then that would be an increase of 5. Well, at least after the first year. But it's just not the increase, right? It's an 80% increase. The percent increase is going to be the thing in parentheses. So that's not what 5 means. Go and read C.
The number of years the restaurant has been open.
That doesn't make any sense. Again, right? That's the T value, is the number of years since the restaurant's opened, right? That's not going to be the value of 5. Does that make sense why we can eliminate C? Even if you weren't sure what the right answer was. And then D, go and read D as well.
The percent increase in the estimate number of employees each year.
That also doesn't make sense, right? Because the percent increase is the thing in parentheses, right? Not the thing outside parentheses. That's the 1.8. That represents an 80% increase. So it's not D as well. You can settle on A just by eliminating the others as well. So, but I think here's helpful to know the original value that you're starting with is outside the parentheses, and then the percent increase is in parentheses. The number of years or whatever the period of time is generally going to be the exponent, which is the case here for T. Questions about that, or does that make some sense?
That makes sense.
Yeah. I want to explain in a little more detail why 1.8 represents an 80% increase. Okay? I'm going to explain that real quick. First, I'm going to explain. Let's start with the remember the 25% increase we were talking about in the rules document, right? Where the 25% increase of X is X times 1.25. Does that make some sense why that's a 25% increase? So, like to calculate, to figure out what you're multiplying by, the thing in parentheses, you can literally just take 1. If it's a 25% increase, it's 1 plus 25%. 25% is 0.25. Does that make sense why 25% is 0.25?
Yeah.
Yeah, and if you add those, you'll get 1.25. That's what you're multiplying by, the thing in parentheses. Does that make some sense?
Yeah.
But if it's an 80% increase, it's 1 plus 80%. 80% is 0.8 or 0.80. If you're unsure about that, like literally just 80% means 80 divided by 100. So just punch that into your calculator, which you got on the digital SAT. 80 divided by 100 is 0.8 or 0.80, same thing. So that's why you're multiplying by 1.8. Does that make sense?
Yeah.
Yeah. Yeah. So that's why that expression's structured that way. But it's helpful to be familiar with that sort of form to know what things mean there. That's really helpful in this question. Any questions before we move on?
No.
Okay, great job. All right, let's do a handful more here. I think that was question number 15, that last one, I think. All right, go and read number 16 for us, please.
G of X equals X to the second power plus 55. What is the minimum value of each of the given function?
Ooh, what are we solving for here, Tanner?
The minimum value.
Yeah, the minimum value of the given function, the minimum value. Minimum means what? What does minimum mean?
Lowest.
Yeah, the lowest, the smallest value. So we're looking for the smallest value for the given function. Now, when we're talking about the smallest value, we're not talking about the X value. We're talking about the G of X value, the output, or you could say the G value, right? So looking for the smallest possible value. You've got some options here in thinking about this question. You know, we could sort of maybe like, I don't know, you plug in these answers and I don't know. No, I wouldn't want to do that. Because, yeah, then we'd have to solve for X there and X being squared. I think the best path here is to plug in values for X and just try to make the G of X value, the output, or the G values, it's all the same thing. Try to make that as small as possible. Okay? And just kind of play with some numbers here and see what happens. Does that make some sense?
Yeah.
Yeah. We're just going to try to make it smaller and smaller and smaller and see what the minimum value is. So what value for X could we plug into? Let's try to make the G value small. What are we going to plug in for X? We're trying to make it small.
We could plug in 2.
Plug in a 2. Great. Plug in a 2 for X. Let's see what happens. What do you get? What's G of 2 equal? So you're just finding 2 squared and adding that to 55.
Yeah.
What's that give us?
That gives us... Let's see. 59.
59. Yeah. Okay, that's pretty small. That's pretty small. And by the way, we already know that we can make G 59, so we can get rid of 2 answer choices here that don't make any sense. What can we get rid of?
D and C.
D and C, easily, yeah. Right? But just by like, okay, let's try to make G small. Can we make it smaller? I think we can.
Yeah.
I think we can. What can we plug in for X to make it even smaller?
1.
Plug in a 1. What do we get?
We get 55.
No, well, what's 1 squared?
Oh, 56.
56. Right. So that's just 1 plus 55. This is 56. So we're getting even smaller. I think we can make it even smaller. What can we plug in to make G even smaller than 56?
0.
And plug in a 0. Find g of 0. And what's g of 0 equal?
0.
Well, no. G of 0 doesn't equal 0.
Oh, 1.
Well, no. I mean, 0 squared is 0, but we still have to add that 55, right?
55, sorry.
So that's going to be 55. Does that make sense?
Yeah.
I think you kind of stopped halfway through the calculation. There's your answer. It's B. Okay. Now, it's a little bit trickier because the answer was A is 0, and like the x value is 0, at the minimum value of the function, but that's not the question. The question is what's the minimum value of the function? That's the output, or the y value, or the g of x value in this case. So that's 55. Yeah. You can't go lower than 55 because you might be like, well, what if I make x negative? What happens if x is negative and we square it? What happens?
The output is negative.
No. Mm-mm. No, let's plug in a negative 2. I just want to show you what happens if we were to plug in a negative. Yeah. If we were to plug in a negative value for x.
Oh, wait.
Yeah. Clear some space here.
It would be lower than...
Well, if we plugged in, let's say like a negative 2. So if we find like g of negative 2. So that would be negative 2 squared plus 55. What's negative 2 squared equal, Tanner?
Negative 4.
No. Punch that. I would punch that into your calculator. And be careful. If you got parentheses, you've got that option. That's not a bad way to do it. But what's a negative times a negative? Is that positive or negative?
Positive.
It's positive. Remember, negative 2 squared means negative 2 times negative 2. That's going to be positive. That's positive 4. Does that make sense? So even if we make even if we make x really negative, like make it negative 10 or negative 100 or negative 1,000,000 or whatever, we're going to get a really big positive number here. Does that make sense? Or no? Why, if we plug in a negative number for x? Does that make sense?
Yeah.
So the way to make the g value as small as possible is to plug in a 0. And again, you could try negative numbers, see what you get. Use that calculator. But you'll just increase the size of g if you make x more and more negative, interestingly here. Or if you make it more and more positive, of course, it's going up as well. Yeah. So it's 55. Questions about that?
No.
Okay. That's not too bad. If you got that Desmos calculator, which you do on the digital SAT, you could also graph this and just pick the smallest y value. But I think if you did that, you'd probably get 55. You would. That's the right answer. Questions about that?
No.
So that's another path too. Let's do a few more questions here. All right, go and read question number 17. I think we were just discussing this concept, actually.
Yeah. Each year, the value of investment increased by 40.49% of its value in a previous year. Which of the following functions best model how the value of the investment changes over time?
Oh, interesting. This is funky, right? Because they don't really give us the equation. I think we could develop it, potentially. But really, if you look at the answer choice here, they're just testing us on the difference between decreasing exponential, decreasing linear, increasing exponential, and increasing linear equations. We're going to talk about the meaning of those terms, exponential and linear, here in just a moment. Before we do that, I think we can get rid of 2 answer choices right off the bat because the question says the value of the investment increases by 0.49% of its value the previous year. Yeah. The ones that are right? Like, it tells us it's increasing. Come on, it's not going to be a decrease here. It's either increasing exponential or increasing linear. It is. By the way, just right now, do you know the answer? Do you know if this is an exponential increase or a linear increase? Do you know what the right answer is here?
It's a linear.
Yeah. I don't think it is. I'm going to explain why here in just a moment. It's a little tempting, maybe, to think it's linear because like, well, it's increasing by the same percentage every year. I want to go to my rules document. I've got 2 examples of increases here at the very end of the document. It's actually in the glossary because I sort of define linear growth and exponential growth in the glossary. I want to take a look at that. Do you see where that is? In fact, I've got 2 images there, 2 graphs, one example of exponential growth, another example of linear growth. Do you see that in the glossary at the end of the document? It's like the last page.
In the gloss.
Yeah, very end of the document. I think it's the last page. I've got
for the rules, or is it in the?
It's in the glossary important terms. Very last page. Just keep scrolling down. You'll see it.
Okay.
You'll see a big exponential curve and a linear, line.
Oh yeah.
Yeah. Do you see it? Go ahead and read the definition of exponential growth through the example at least. I'll give you an example.
Y equals 2 to the 2 to an unknown power. Yeah. Will look like this.
Okay, so exponential growth, you're going to get that big curve. Do you see that with exponential growth? So there's lots of things that grow exponentially, like human populations grow exponentially. Generally, investments grow exponentially, right? Because you're increasing. You're not increasing by the same amount every year. You're not, right? Like you might be increasing by the same percentage, but let's say it's increasing by 7% every year, and you've invested $100, like in that example I gave you previously. The first year, if it's $100 initially, it's a 7% increase of 100. But then the second year, you're increasing by the 7% of the amount in the account, and there's a new amount in the account. There's a bigger amount in the account. So it's 7% of the bigger amount the next year. Does that make some sense why the growth is going to accelerate in an investment? Does that make some sense or no? You can say no, it doesn't make sense. Yeah, and so the question with exponential growth versus linear growth is, okay, is the growth constant or is the growth changing, generally accelerating year over year? And if the growth is changing, then it's going to be exponential. If you're adding the same amount every year, you're going to get a line. You're going to get a linear equation, linear growth. Because over some period of time, you're going to be adding the same amount every year. So if you're adding the same amount, then it's linear. If the rate of change is constant, it's linear. If the rate of change is changing, it's exponential. Does that make some sense?
Yeah.
Yeah. So the right answer here, of course, the rate of change is changing because you're not adding the same amount every year. Even though it's the same percent increase, it's the same percent increase of a different amount. So it's increasing exponential. Does that make some sense?
Yeah.
Okay. Let me show you what that would look like here, that expression. Let's say you're investing $100 in this stock. So the original value is outside the parentheses. Remember kind of how we were structuring that in the previous question? In parentheses would be the percent increase. Now, what would you be multiplying by here? Some students might think, well, it's 100 times 1.49. That's a little bit tempting. But that would be a 49% increase every year. And we're not dealing with a 49% increase here. We're dealing with a 0.49% increase. Does that make some sense?
Yeah.
Yeah. So remember, what you're putting in parentheses here, what you're multiplying by, is going to be 1 plus the percent increase. What does 0.49% look like? Well, I'm going to punch that into the calculator. I want you to do the same. I want you to punch in 0.49 and divide it by 100. That'll give you what you're multiplying with the decimal form of 49%. What do you get when you divide 0.49 by 100?
0.0049.
Yeah, plus 0.0049. So the thing in parentheses is going to be 1.0049%. That's less than a 1% increase, right? If it were 1%, it would be 1.01, what you're multiplying by. That's less than that. It's a very small increase. It's not going to increase by a ton, but that's like, say, T's years or something like that. That's what that expression would look like. Does that make some sense?
Yeah.
Yeah. Not essential here. You don't have to develop the expression. We could see some other questions where that's useful, so I kind of want to point that out here. But be aware, if you're talking like population growth or something like that, or like the value of an investment, unless they tell you in the question you're literally adding the same amount every year, which is impossible, but if it's an investment that some amount increases, compounds every year, then we're dealing with exponential growth. All right. We got one more question. I'm going to wrap it up here. Now, we're talking about percent increase here, right? This is handy. This is handy to know. Some of the stuff we were just discussing. So go ahead and read question number 18.
The population of Greenville increases by 7% from 2015 to 2016. If 2016 population is K times the 2015 population, was the value of K?
Oh, what are we solving for here, Tanner?
The value of K.
The value of K. And K is the number of times, based on some term times the 2015 population. We got to figure out what that K value is. I want to start thinking in concrete terms here. I want to come up with like a population for the city of Greenville. Okay, and I'm going to try to keep this as simple and straightforward as possible. I'm going to make the population 1,000. Does that make some sense? Yeah, like it just makes sense. Percents, you're dealing with multiples of 100 or some number out of 100. So I think it's going to keep it pretty straightforward. And we're increasing that population by 7% from 2015 to 2016. Okay. What would we multiply by to calculate what the population is in 2016? So it's a 7% increase. What do we multiply by for a 7% increase? We were kind of just discussing it.
0.07.
Well, if we multiply by 0.07, I want to do that real quick. Well, I want to do it. Yeah. I want to start by multiplying by 0.07. Start there. Tell me what you get if you multiply 1,000 times 0.07. Let's do it together. I'm going to punch it in my calculator. What do you get?
1,070.
Well, not if you multiply by 0.07. I'm doing 1,000 times 0.07.
Oh,
what do you get?
just 5.07.
Yeah.
70.
That gives you 70, right? Now, if you multiply by 0.07, you're finding 7% of 1,000 if you're multiplying by 0.07. Does that make sense? You're not going to get the population in Greenville after a year, after a 7% increase, by multiplying by 0.07. You're finding 7% of 1,000. Does that make sense, Tanner?
Yeah.
Yeah. So, and the increase is 70. You're literally calculating the increase there. That's fine. You can add that back to 1,000. You'll get the answer. So, but I recommend multiplying by, what do we multiply by to calculate the population after a 7% increase? What do we multiply by?
1.07.
1.07. And that should give us 1,070.
Yeah.
Does that make some sense?
Yeah.
Yeah. So this is the 2016 population. I'm going to make a note of that. Okay. And that's the 2015 population. Whoop, right there.
Yeah.
Questions about that? Or are we good so far?
No, we're good.
Okay. Now it says in the question, the 2016 population is K times the 2015 population. What's the value of K? You might be able to sort of like, you already got it. You already circled it, right? Like, there's an equation there. You could sort of structure it. You could be like, well, the 2016 population is 1,070, and that equals K times the 2015 population, which is 1,000. And then you're just dividing by 1,000. Does that make sense? Where you can sort of develop an equation and calculate it?
Yeah.
Yeah. Or you just look at it and be like, hey, we multiplied by 1.07. The answer is probably 1.07. And that works too. Zoom out a little bit. There you go. But you got some options there. But percent increase, it's worth knowing on this test. All right, let's take a little break there. We'll finish up a recording on the rest of the questions here on Digital SAT Practice Test 1 Math Module 2 in another recording. Tanner, you've been great. Really appreciate your participation. And make sure to like this video, subscribe to my channel, all that stuff. And I'll catch you guys around.